So our problem statement states that the double pulley shown has a mass of 3 kilograms and a radius of gyration of 0.1 meters. Knowing that when the pulley is at rest, a force of P with a magnitude of 24 newtons is applied to cord B, and it's asking us to determine the velocity of the pulley after 1.5 seconds and the tension in cord C. So we were given a few things from this problem statement, such as the radius of gyration is equal to 0.1 meters, the mass is equal to 3 kilograms, the force applied to cord B is 24 newtons, the radius of B is 0.08 meters, and the radius of C is 0.15 meters. And we were also able to determine that T1 is equal to 0 seconds and T2 is equal to 1.5 seconds. So we were also able to assume a couple things. So we know that at state 1, the angular velocity is equal to 0 because the pulley is at rest. We also assumed that clockwise was positive and up was also positive. We know that G is equal to 9.81 meters per second, and the instantaneous center is at point C. And because the instantaneous center is at point C, we know that V is equal to W2 R sub C. We also know that the pulley is in pure rotation, and because of this, the velocity is positive and vertical. So we were asked to determine the instantaneous center, and we know that it's at point C is because this model, when the force is applied to cord B, the black tape here doesn't move, so we know that it's rotating around this point.
So now that the givens and assumptions have been stated, we can draw our impulse and momentum diagrams. So we have state 1, for which the pulley system is at rest, and then the impulse is being applied, which causes there to be an angular velocity as well as a velocity, which is shown in state 2. So part A of the problem asks us to find the velocity at time t equals 1.5 seconds. So the first step is to write out the equation for impulse momentum, which is I omega 1 plus the integral from t1 to t2 of the summation of the moments about g dt is equal to I omega 2. And if we were to do this, we would notice that we would have 3 unknowns but only 1 equation. So it's more advantageous for us to take the moments about a point to eliminate one of the unknowns. So instead of taking about the center of gravity, if we were to take the moments about C, that would get rid of the tension in cord C. So we can rewrite this equation as I times omega 1 plus the integral from t1 to t2 of the summation of the moments about C dt is equal to I omega 2 plus mv rc. And the reason we add this mv rc term on is because when you're not taking the impulse about the center of gravity, this term gets added on. But even with this, we still have 2 unknowns and only 1 equation, so we need a second equation to get rid of one of the unknowns. And we did that by using this equation here. Velocity is equal to the radius of C times the angular velocity, the final angular velocity. And the reason we did that is because we determined before that the instantaneous center of velocity was at point C, so we're allowed to apply this equation. So when we substitute that in, we get I times omega 1 plus the integral from t1 to t2 of the summation of the moments about C dt is equal to I times omega 2 plus m omega 2 r of C squared. So now we have 1 equation and just 1 unknown, which is omega 2, so we can plug in everything. And throughout this, we're assuming that clockwise is positive. So when we're taking our moments about C, we're assuming clockwise is positive. And we can plug in all of our numbers. And for I, which is the polar moment of inertia, we calculated that through the equation I is equal to m times the radius of gyration squared. So that's how we got the 0.03. So when you plug all that in and you simplify and you solve, you end up getting an angular velocity of 17.0077 radians per second. And then from there, you can plug in to the velocity is equal to R of C omega 2, knowing that R of C is 0.15 meters and omega 2 is equal to 17.0077. And when you do that, you get your final answer for the velocity after 1.5 seconds of being 2.55 meters per second in the upward direction.
We were tasked with finding the tension in cord C. For finding that, we used the momentum impulse equation in a different variety of those, so we could adapt to what numbers we did and didn't have. From there, we took what values we had from earlier problem, plugged it in, and we're left with 1 unknown, which is the tension to C. From there, we took all of our values, plugged them in, solved, and ended up with a tension in cable C of 10.53 newtons.